All right, greetings liberal arts students. Going through our next chapter at 7.3, as you can see on the board there, it's called Shapes of Distributions. Okay, it's looking how our data is, what shape it forms when you graph it, and then using that shape to help you determine what is the best measure to analyze this information. That's what this whole lesson is about, is how can we best analyze information given to us to help us make better decisions. Okay, that's the whole message we're getting through. So this lesson is looking at how the data is distributed and helping us make the right decisions for how we explore that data more thoroughly. So in this lesson, you're going to learn how to describe the shapes of data distributions. You're going to use the shape of data distributions to choose appropriate measures, and then you're going to compare data distributions. So the first thing says, describing the shapes of data distributions. It says to recall what's called a histogram is a bar graph that shows the frequency of data values in intervals of the same size. A histogram is another useful data display that shows the shape of the distribution. So what you might call a bar graph, we're calling it a histogram, like historygram, right? So what you see here, let me come over to the TV screen. You've got three different shapes. You've got two that are skewed. Remember, we've talked about skewed already. Data that is not in the middle of things in general. So we've got one that is skewed left, that the tail goes more to the left. This is called skewed left. It looks like right because the bigger stuff goes to the right. This book is calling this to be skewed left. The tail determines the skew. Okay? Most of the data are on the right-hand side. Here we see symmetric. It's mostly right in the middle, laid out. They drew this perfectly. Almost never will your data look perfect for the center, but roughly it will look that way. All right? And then here we have skewed to the right. You see that most of the data is to the left, with the tail extending off to the right. So this is called skewed to the right. Basic, just vocab that you need to know. So, describing the shape of the distribution. So we have this frequency table. It shows the number of raffle tickets sold by students in your grade. Display the data in a histogram and describe the shape. So let's just look at the table really quick. They've broken down the number of tickets sold into groupings. 1 to 8 tickets sold. If you sold up to 8 tickets, that was 5 people. If you sold between 9 and 16 tickets, that's 9 people. 17 to 24, etc. These are the brackets to determine how many sold in this range. Okay? And here's how they did that. So, if you build a table, a histogram, on the bottom of that histogram, you can see here, they put the number of tickets sold, and please label your histograms. A histogram is of no value if you don't tell what each of the data points represent. Right? So that is critical. Please label your data points. So on the bottom is the number of tickets sold by their groupings, and then on the column side on the left is the frequency. How many people sold in these ticket amounts? Okay? So what they ask you is, how would you describe that data? Would you describe this data as skewed to the left, skewed to the right, or symmetric? Well, let's draw a line and see what it looks like. We draw a line connecting the corners. The question is, how would you describe it? Now, I know when you look at it, you see how it's kind of shifted just slightly right. That shift is not significant enough to call it skewed. In general, this would be called a symmetrical distribution. The vast majority of our tickets have been sold here in the middle, with some edges on the right and some edges on the left. So this is a symmetrical data distribution. So here's what I want you to do now. It says the frequency table to the left shows the number of pounds of aluminum cans collected by classes for a fundraiser, display the data in a histogram and describe the shape of the distribution. So we look over here at the table they gave us, the number of pounds of aluminum collected, and how many people collected those number of pounds is on the right in the frequency. So, substitute teacher, you're going to pause here, and students, please create a histogram with this information. And when we come back, I'll show you mine and see if it looks like mine as well. So please pause now. Okay, so we're back. So let's come over here to my histogram that I created. Number of pounds on the bottom. We have our different frequencies, and then our number of people. Let's see how well I can write sideways. Okay, how many people selected that? And so I've already graphed it ahead of time based on the numbers in that. I went by intervals of 5 here. It doesn't matter, whatever you choose, just make sure the intervals are the same, whatever they are. 2s, 5s, 10s, right? Then, let's come along, let's draw our tail and our shape. And that's what our shape looks like for this frequency, this histogram table. I'm hoping you can clearly see that the majority of the data is slid over here to the right-hand side. That means that this is skewed left. Remember, the tail is what determines the skew, not the data majority. So this is skewed to the left. All right? So our next thing now, how we use this is, we're going to go back and use some of our previous information to help us now. It says, use the shape of a distribution to choose the most appropriate measure of center and measure of variation to describe the data set. So these are rules you need to know. If the data distribution is symmetric, where the majority of it is here in the middle, the best way statistically to measure that data then is to use the mean to describe the center and to use the standard deviation to describe the variation. Okay? If it's symmetrical, we use the mean and the standard deviation. If it is skewed, you use the median to describe the center. And then you use the 5-number summary. Remember, the 5-number summary came from our previous chapter, the box and whisker plot. You get the 5-number summary then to spread out the data for you to analyze. The whole point of this is, how can I best analyze this information to help me make decisions? That's the long-term goal of this. And I promise you, the majority of you in your lives are going to use statistics like this to help you make decisions. If you advance at all in any kind of leadership or own your own business, you will need to analyze statistics to be successful. So let's look at this example. Choosing appropriate measures. A police officer measures the speed in miles per hour of 30 motorists. The results are shown in the table at the left. Display the data in a histogram using 6 intervals beginning with 31 to 35. That's the first thing you're to do. And then secondly, which measures of center and variation best represent the data? And finally, they want you to answer this question. The speed limit is 45 miles per hour. How would you interpret these results? So here's the table of these motorists. Zoom back out a little bit. Okay? So they looked at 30 motorists and took their speed, what they were traveling at. Then he lumped them into a table you see here. So those going 31 to 35 are just one person, one driver, going 31 to 35 miles an hour, probably a grandma. 36 to 40, 41 to 45, 46 to 50, 51 to 55, and 56 to 60. Those are the teenagers. All right, these are the distributions by 5 miles per hour to people he took going in the speed in this zone. So then we made a histogram of that. And here's what that looks like. we've got our 6 breakouts of 5 by 5 miles an hour, and how many were found each going that distance. So the next question asked is, what is our best measure for determining and interpreting this data? Well, let's draw our bell. Hopefully, clearly you can see this is skewed to the left. The tail's longer at the left-hand side. So if it is skewed, we use median and our 5-number summary to determine this best data. So our median is going to be somewhere right in this zone right here, 46 to 50. The last question it said was, the speed limit was 45 miles an hour. How would we interpret what we see here on our histogram based on that information? Clearly, the vast majority of drivers on this section of the road are speeding, right? Going over 45 miles an hour, since that's what this is here and to the left. So it's going to be your turn now to do your own. It says here, you record the number of email attachments sent by 30 employees of a company in 1 week. Your results are shown in the table. Describe or display the data in a histogram using 6 intervals, and which measure of center and variation best represents the data, and explain. So you're going to have to bear with me, beginning with 1 to 20. I did not pre-create this one, but that's probably going to be helpful for you to watch me set this up after you give it a try. So, substitute at this point. Please pause. All right. So we're going to come back now. Start by making our table. Marker seems to be dying. Let me see if this one's better. And it wanted us to do it at intervals of 20. 1 to 20, 21 to 40, 41 to 60, go up to 120, 61 to 80, 81 to 100, and 101 to 120. And then how many in each of those sections? So how many went 21 to 40? I see 1, 2, 3, 4, I see 5. 41 to 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, I see 9. 61 to 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I see 10. 81 to 100. 1, 2, 3, 4. And 101 to 120, 1, 2. You see how my numbers add up. So that's 5, 14, 24, 28, that's 30. Perfect. That's how many we needed. So I've got them labeled and laid out by where they're at. Now, we make our histogram. So I've got 21 to 40, then I've got 41 to 60, I've got 61 to 80, I've got 81 to 100, and I've got 101 to 120. And up here, I'm going just by tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 2, 4, 6, 8, 10. And I graphed it now. So 21 to 40 is 5. That's right here, up to 5. 41 to 60 is 9. That's here, up to 9. 61 to 80 is 10. That's here. Okay. 81 to 100 is 4. That's here. And 101 to 120 is 2, and that's here. All right, so I've made my histogram now of this data distribution. And so now let's make my bell. So now we interpret that data. What I would like you to see, again, calling it symmetrical does not mean it looks exactly the same, but it looks close. This primary bell is hit right in the middle, right in the middle, with some tails on either end. This data is distributed symmetrically. The average is going to lie right here somewhere between 61 and 80. So to describe this data, we're going to use the mean and the standard deviation. And that's all you need to find out. It's not even asking you to calculate it right now. Just describe what you would use to describe this. The mean and the standard deviation, because it is symmetrical. All right, last thing is to compare data distributions. So in this last thing, we've got two different things we're comparing. It's comparing data distributions. Emoticons, you're aware of what emoticons are. The double histogram to the right shows the distributions of emoticon messages sent by a group of female and a group of male students during 1 week. How many emoticons in their text did they send out? Compare their distributions using their shapes and appropriate measures of center and variation. So we look here on the top one is the females and how many emoticons they use, and the males and how many emoticons they used in 1 week's time. So if we draw our two bells, what you should clearly see here is the female is distributed symmetrically. So we would use the mean and the standard deviation to describe this data, whereas the males is skewed to the right. The tail's on the right-hand side, so we would use the median and the 5-number summary to compare these, right? And how you interpret this is, clearly you can tell, this probably is not a surprise to you all. The average female uses, on average, 30, whereas the average male uses somewhere around 10. And that may not be a surprise to you to know that the ladies, at least in this book, use way more emoticons in their texting than guys do. So the other thing it asks to describe it says the data for the female students is more variable than the data for the male students. This means that the use of emoticons to differ more for females than it does for men. So as you can see here is the data is distributed greater for the females. Here's the majority, but it's spread out. Versus the males, the vast majority is all the way over here with nothing on this end. So females vary much more in how they use them. Males are all going about it more consistently with each other. Last monitoring progress to do, and then we'll wrap up this chapter. It says compare the distributions using their shapes and appropriate measures of center and variation. Professional football players versus company employees and their years of experience. So let's pause here for just a moment while you work on this. Shouldn't take you about a couple of minutes. Go ahead and please pause now. All right, and we're back. So, draw our bell, and draw our bell. Okay? So as far as number of years being a professional football player versus number of years of working for a company, clearly you can see professional football players, the data is skewed to the right. The tail is longer on the right-hand side versus the company employees are very symmetrical. Okay? And that should make sense. Common sense would tell you football players are not in the profession very long. They're young, they get injured, they have to go. Employees at a regular company are generally spread out to this, like this. So if you want to know what the best way to assess that data is, you use the median and the 5-number summary. For the symmetrical, you would use that mean and the standard deviation. And that's what we're looking for answers for this. So here I want to show you the one last thing I want to show you. The table shows the results of a survey that asked men and women how many pairs of shoes they own Make a double box and whisker plot that represents the data and describe the shape of each distribution. Compare the number of shoes owned by men to the number of pair of shoes owned by women, and about how many of the women surveyed would you expect to own between 10 and 18 pairs of shoes. So here's the table between men and women, how many were surveyed. There's their 5-number summary, okay, in addition to their mean and standard deviation. So here's what they look like for their box and whisker plots. You've got the women in blue, the men in pink. They reverse that, that's funny. As you can see here, the distribution for the men is skewed to the right. If you remember box and whisker, 50% of all men surveyed were right in this zone, whereas 50% of all women were in this zone, okay? So the distribution for the men is skewed to the right. The majority is here, the tail's longer on the right, it's skewed to the right, while the women's distribution is more symmetrical. The centers and the spreads of the two data sets are quite different from each other. The mean for women is twice the median for men, right? Here's the mean, the median is 7, the mean is 14. Okay, so the women on average own twice as many shoes. Not a shock there. And there's more variability in the number because the range is so much greater. You go from 5 to 24, a range of 19, versus 2 and 17, a range of 15. So your data is more variable here than it is here. And then what it says here at the bottom, assuming the symmetric distribution is bell-shaped, you know about 68% of the data lie within one standard deviation of the mean. I'll describe this more when I see back with you. Because the mean is 14 and the standard deviation is 4, the interval from 10 to 18 represents about 68% of all the women. So if this is our mean of 14, our standard deviation is 4, which is from 18 to 10. This set right here represents 68% of all people and all women surveyed. That's how you understand standard deviation. All right, and we're going to stop there. It's a lot of information. There's not really hardly any math to go through. It's more about a data interpretation. So at this point now, you've got a homework assignment I want you to work on. We'll go over it together when I return from the trip. Great job. See you soon.